This is topic 5, recording 2. Continued. So the central limit theorem is essential when it comes to testing hypotheses, okay? So the central limit theorem states that given a large enough sample size, the sampling distribution drawn from any population will have a mean equal to the population mean and a standard deviation equal to the standard error of the mean, which is the standard deviation of the population divided by the square root of n. So this means a couple things, okay? First, it means that the sampling distribution around the mean is normally distributed, okay? Also, what this means here, the sampling distribution is just the distribution of all the sample means, all right? So let's look at that in the next slide. The distribution of all possible sample means from a population. So for example, we can take 1,000 samples of n equal 100 and we'll get their mean, and this mean will be the mean of the sampling distribution. Will be equal to the mean of the population. So these are the 1,000 means make up a sampling distribution. So a sampling distribution can be 100 means, 1,000 means, 2,000 means, right? And the larger, more means, and the larger the samples, the closer it's going to be to the true population mean. But basically, the mean of any sampling distribution of the means will be equal to the population means. Okay. Frequency distribution of all possible means when an infinite number of samples of the same size n are randomly selected from one raw score population. Random selection is essential, as we've spoken about before. So n equal 5 samples 1,000 times, their means will form a normal curve, a normal distribution, and so forth. And their mean will be the population mean. So what this also means is that to get a sample mean that is far from the population mean, all of our cases have to be extreme scores. And this is why when we form that sampling distribution of the mean, almost all of them, right, they're going to be close to the mean. So here we have a population, 68% are going to be within one standard deviation of the mean, right? So when you draw a random sample, the larger the sample size, the more likely that the sample mean is going to approximate the population mean, right? Whereas a small sample, you could have all very extreme scores out here if you only take 5. But it doesn't matter, because if you draw enough samples and make a sampling distribution, because the majority of the scores in any population are going to be within 1 or standard deviation of the mean, and 95% within 2, it's going to form a normal curve in the end, right? So let's rephrase the central limit theorem more simply. It tells us that the sampling distribution of the means is approximately normally distributed, has a mean, mu equal to the mean of the mu population, mu of the underlying raw score population, and has a standard deviation that is mathematically related to the standard deviation of the raw score population. This just means it's the standard error of the mean, okay? Which is just standard deviation over the square root of n, all right? The standard error of the mean is the standard deviation of the sampling distributions of the mean, right? And this is this thing that I just drew. Standard deviation of the population divided by the sample size. And it's part of the margin of error, and we use it to construct confidence intervals and so forth. We'll get to that later. And the reason we need this is because we are going to use our samples to make inferences about populations using, in this class, null hypothesis significance testing, which we will get to in a couple of topics. All right, if you have any questions, post on the FAQ and email me if you find no answers there.